Section 4. So we're going to talk about experimental research here. Scientists, they go crazy for experimental design because they always want to demonstrate cause and effect relationship, like I said. So basically here, you're gonna manipulate one variable and you're gonna see the effect on the second variable. So you have cause and effect. One gonna be cause, one gonna be effect. You're gonna control everything else. Like if you have 10 variables, you're gonna consider only 2 of them and control the rest of them, like the other 8 ones. So the 2 variables gonna be independent variable or IV or dependent variable or DV. I'm gonna use those terms a lot, so just memorize them. So IV or independent variable gonna be the one that you're gonna like manipulate them, or you're gonna just change them to see the result on DV. So DV or dependent variable gonna be the one that you expect to see the change. I know it's just so sophisticated at this point, but it's just so easy. For example, if you are studying, let's say, sleeping hours and the mood after that, you're gonna just manipulate the time, like sleeping hours, like you're gonna just have 4 hours and 8 hours, and you're gonna see the result on the mood as like the variable that you expect to see the change. For example, you expect that a person who would sleep like 4 hours would be grumpy the day after, yet a person who would sleep like 8 hours, they would be happy, healthy, and just positive all the time. So one IV, one DV. If and you would control for age, for example, for sex, like you would just study only 20 years old people and only females. So it's going to be control variables. Make sense? We had 4 variables. IV was the hours, DV was the mood, and we control age and sex. We are good to go. Here's another example. Always in experimental design, we have to randomize the population. And if you remember, it is the only point that was different from quasi-experimental, okay? So after randomizing the sample size, we're gonna have 2 groups. Group number 1 gonna be the experimental group. Group number 2 gonna be control group, okay? In experimental design or group, again, they are kind of same because we're gonna study both of them and we're gonna just have the research question for both of them. Yet, for the experimental group, we have IV. We have one variable that we're gonna just manipulate that. We don't have anything in control group. They just do whatever they're gonna do. Like we don't control their sleeping hours. We don't care about that, but we're gonna study them because we're gonna see that whether sleeping hour gonna be important or not at all. So the depending variable gonna be same. It's gonna be mood after that. Okay. So everything between experimental group and control group gonna be same except the IV, the independent variable. So control variable, independent variable, dependent variables, they are very important. President Obama, he said that. So just memorize them. There are going to be some problems in experimental research. We have experimenters bias. Like sometimes if you know about the research question, if you know about like what participant is in control group versus experimental group, your behavior gonna change. For example, I'm telling you, one time we were conducting a study on literacy level of bilingual Hispanic people. Like it was like they could speak Spanish and English, but they didn't have proper education in English. So like from the beginning, we had an assumption that they wouldn't be as compatible as an English native speaker in their test, in their literacy test. We had that bias. It was wrong because actually they were just so good because I mean they were reading every question like 10 times, but native speakers, they were just kind of confident because they thought that they know everything about literacy. They didn't pay attention to punctuation, that kind of stuff. So their grades were actually lower than the Hispanic group. So you shouldn't have any bias. And if you feel like you might have any bias, ask another colleague or someone in your research team that is not aware about the actual research question. That's the solution. Another one is participant bias. If participant would know a lot about the research question, like if you actually explain every step of your experiment and you literally tell them that, hey, I'm studying, for example, sleeping hours and your mood tomorrow. So this is a research question. So definitely, I mean, some of them want to just be nice with people because they know about the research question, and for example they want to say that, oh, sleeping hour is not, it's not important at all, so they would be super positive, friendly the day after. Yeah, they are grumpy inside, but yeah, because they have bias, they know about the research question. So there are two ways for cover experimenter bias and participant bias. We can do single blind study, which means the experiments gonna be conducted in a situation that the experimenter doesn't have any idea about the research question. Okay, it's gonna be single blind one. Double blind study means like whenever both participant and experimenter, they are just blind. They literally don't know what they're doing. They have some protocol or like guidelines, and they would just follow that, and they are good to go. So it just depends on your research questions, depending on your like protocol or your IRB. You can do yourself. I mean, you can do whatever you're gonna do. So, but there are some solutions here. Oh, there is a video. It's very helpful if you are interested in experimental design. Watch them and have fun. So let's talk about how we should select our participants. Here we have a population. We always try to have a sample size out of that population that could just actually represent that population. For example, here you can see different purple. We took one purple here to have that person in our bucket. Or here you can see, I don't know, like maybe a green one. You have a green here as well. Imagine we're gonna study freshmen sleeping hours and their attitude the day after, their mood the day after. So we cannot just study every freshman at GSU, right? For example, I don't know, maybe there are just 5,000 freshmen in GSU. So we cannot do that. So we're gonna just try to have different races, people of different backgrounds in our samples, people of students of different departments, to have a good and decent sample size. So sample size is going to be always smaller group of that population, and for experimental research, it has to be a good representative of that population. For that aim, we can just randomize participants, like we can just randomly pick some people from every department to just make sure we do have representative. And we can just randomize the assignment as well. For example, you got a random sample size, like you have every possible races, ages, I don't know, departments for your research. But if you wouldn't randomize them based on the assignments, again, it's going to be a problem. For example, you have the sample, you have to randomize them for control group and experiment group. You cannot say that, okay, 1, 2, 3 goes to experimental group, but since I like number 7, 8, 10, they would go to control group because, you know, I don't want to just make a problem for their sleeping hours. They are my friends and I like them. No, it shouldn't be like that. You're literally going to randomize everything, both for assignment and both for sample size. Here is a good example. You can see that, okay, this is population, all the freshmen. Here is a random selection. We can see that we have like 4 pinks, right? And 4 blues. Good job. But for the assignment part, we didn't randomize. So in control group, we only have pinks, but in the treatment group, we only have blues. It's not a good representative. It's not an experimental design, so it does have problem. Go back to whatever I said about quasi-experimental design and tell me what was the main difference between quasi-experimental design and experimental research.